Hi everyone. Today I am going to present an interesting research work related to security evaluation of HelloCFT'22 benchmarks. Before moving next, let me introduce who we are and where we belong. Our group consists of 4 members and a professor from Center for Hardware Security at Tallinn University of Technology, Estonia. From right to left, Samuel Pagliarini is our head of the group. And next, Mohammad Eslami and Felipe Almeida are early stage researcher. And then it's me, Zain Ul Abideen. I am also working as an early stage researcher. At the end, Levent Aksoy is postdoctoral researcher in our group. Concerning the logic locking, it is based on corrupt and correct principle. If we look over this figure, we have 2 different circuits. One circuit represents the corrupted circuit and the other one is the restore logic. So we can easily extract and differentiate between these 2 types of units in the obfuscated design. The corrupted circuit has a large number of primary inputs which are connected with a NOR and NAND gates, and which is further input of a restore unit, which is shown in this figure. And from our analysis, we assume that this is a part of protected input pattern. Let's discuss the attack algorithm and results for the logic locking. Concerning the oracle-guided attack, we have developed a tool that performs the structural analysis and exhaustive search to find the secret key of the obfuscated circuit. It can find all the keys for the provided benchmarks. Related to the time, it just takes less than 5 minutes to find all the secret keys. On the instance the oracle-guided attack, we have developed a resynthesis-based attack that is given on our paper, and it exploits the corrupted circuits to find the relation between the primary inputs and the key inputs. And then it can discover the secret key for all 3 different types of the benchmarks with higher accuracy. Another obfuscation technique is state-space obfuscation. So it exploits non-functional states in the finite state machine to incorporate exponential increase in the state space reachability. So this is the locking. If we look over this figure, we have 3 different types of the state space. One state space machine is dummy state space machine. Other one is the original, that one is the protected, and another one is a part of the circuit which are the states for the authentication. Let's discuss the attack procedure and results for the state space obfuscation. We started by analyzing the flip-flops in the obfuscated design, and for this we thought that we should find the strongly connected flip-flops in the original FSM using data tool, and then it doesn't work a lot. And then we started to find the relative scores using ATPG and rank their scores, and then feed this information to the redaction tool in data to find the input pattern. This gives us a much of information, but it doesn't give us the correct pattern. Next, we started to build our custom tool to extract the flip-flops that belongs to the original design. And then we explored all possible states that are actually the next state and the original FSM, and then find the state that are connected in the authentication region. Let us discuss another obfuscation technique, which is actually fine-grained hardware redaction. The idea of this technique is to pick a gate or gates from a combinational or sequential circuit and then convert into a lookup tables using a key bits. These lookup tables are implemented at gate level, and we can easily identify and extract them from the obfuscated netlist. During our analysis, we found that there are 3 different realizations of LUTs, which are 2 input, 3 input, and 4 input LUTs. And these LUTs has further variants. For example, 2 input LUT has 4 different variants, and 3 input LUT has 11 different variants, and 4 input LUT has 4 different variants. So for the example, we can see uh, architecture of one of the variants for these LUTs. So the two input LUT is a simple mux, and three input LUT is also a simple mux, which consists of three different muxes. And then a little bit complex architecture of four input LUT, which consists of a mux and different type of gates. Next, let us discuss the attack algorithm results for the fine-grained hardware redaction. Regarding the Oracle guided attack, we first thought that we should try the state-of-the-art logic logging attack, and this doesn't work for the larger circuits, but we found a partial solution for the low benchmarks. And then we started to develop another attack strategy that can easily handle the larger benchmarks. What it does, it iteratively map a set of logic gates into the original design, and on the same time it maps the gates into the large modules in the obfuscated design. So now we have two different types of smaller circuits. We feed these to the QBF solver and we found a key, and this goes until we found all the LUTs. Concerning the Oracle-less threat model, we have developed an attack that guesses the key and performs the structural analysis with the help of the ATPG analysis. And this provides us a key guess. I mean, we cannot sure that it is the key. So we have provided the partial solution for Oracle-less attack to all the benchmarks. Last but not least, another obfuscation technique is routing table configuration. This obfuscation technique configures the routing of input pins for the routers with the help of multiplexers. So the circuit that was provided during the competition, it consists of 12 routers, and 4 out of them were obfuscated. So in this figure we can see that these are the inputs of the router, and they are coming from the configuration of the muxes. So we have to provide the selection pin, which is actually the configuration key, to route the router towards the correct path. As said earlier, that 4 routers were obfuscated, so we provided a solution that connects the pins from one router to the other, and we have provided this on the basis of the assumption. So we provided the select input of the muxes in the form of the key bits. Let's conclude this presentation. For the logic locking benchmarks that fall under the category of Oracle guided threat model, we found all the secret keys for all the benchmarks. And for the benchmarks that are related to Oracle-less threat model, we also found the keys with higher accuracy. And for the state space obfuscation, we provided a set of flip-flops that actually belongs to the original design in the obfuscated design. And for the fine-grained hardware redaction, we have been developing a tool that is based on Oracle guided threat model. And for Oracle less threat model, we found a key that is actually a key guess, and we provided the solutions. For the routing table configuration, we found a key that is actually a key guess. This key guess is a configuration of the muxes that routes the path of the routers in the obfuscated design. Thank you for your attention. If you have any query or remark, or if you would like to give us any suggestion, please don't hesitate to contact on the following email. On the other hand, I would like to thank all the organizers and managers who successfully conducted this event, and have a nice journey for the next year. Thank you.